Okay, so today we're going to talk about the cerebellum and how information comes to the cerebellar cortex and then is transferred out of the cerebellar cortex. So to start, we have three layers of the cerebellar cortex. We have the most superficial layer being the molecular layer, which includes parallel fibers, mainly, climbing fibers, and dendrites of the Purkinje cells. The middle layer is the Purkinje cell layer, which, as you would guess, has Purkinje cells. Then you have the deepest layer of the cerebellar cortex, the granule layer, which has granule cells, Golgi cells, and basket and stellate cells. So, here you see the molecular layer up top with the parallel fibers going straight across. Then you have the Purkinje cell layer with the Purkinje cell. You see its dendrites going up to the molecular layer. Then you have the granule layer. You see the granule cells, mossy fibers are synapsing on them, and then the climbing fibers coming up to the parallel fibers in the molecular layer. So there are two efferent fibers that help bring info to the cerebellar cortex. We have the mossy fibers and the climbing fibers. The mossy fibers have one piece going to the deep cerebellar nuclei, and you have one synapsing on the granule cells, conveying info to the parallel fibers in the molecular layer, which then brings info to the Purkinje cells. These fibers will excite the granule cells with the neurotransmitter glutamate, which will cause a weak action potential, even though it's high frequency. The mossy fibers will receive afferent input through the spinocerebellar pathways and the other cerebellar afferent pathways. So right here we have them listed. So the spinocerebellar will have the anterior spinocerebellar, the posterior spinocerebellar, the rostrocerebellar, the cuneo-cerebellar. Then for the other cerebellar afferent pathways, we have the raphe-cerebellar, the reticulocerebellar, the pontocerebellar, the hypothalamocerebellar, and the ceruleocerebellar. It's a lot of them. Okay, so then the mossy fibers will help convey somatosensory, arousal, equilibrium, and cerebral cortex motor info. So then we have the climbing fibers. The climbing fibers come from the inferior olivary nucleus, and they convey info regarding movement errors. And they're usually most active when there's a problem with movement. There's something wrong. They'll synapse with the Purkinje cell dendrites, and then these fibers, they will excite the Purkinje cells through parallel fibers with glutamate also. But these will cause a much stronger action potential. They'll be less frequent, but they'll produce a stronger action potential than the mossy fibers will. Then, when the Purkinje cell is excited by the climbing and mossy fibers, it will produce an inhibitory signal through the neurotransmitter GABA, which is an inhibitory neurotransmitter. The Purkinje cell projections inhibit the cerebellar nuclei and vestibular nuclei, which prevents the info from leaving the cerebellum via the efferent fibers. So for deep cerebellar nuclei, from medial to lateral, we'll have the vestigial, the globus, the emboliform, and the dentite nucleus. So for output, the efferent outputs of this system, how information gets out, your main efferent neurons will be your Purkinje neurons. The main output, which is considered to be the main output from the cerebellum, it's considered a corticonuclei neuron, and it will receive its info from the corticonuclear pathway. So that's basically the idea of it. So you can think the climbing fibers, climbing takes more strength, so stronger action potential will be produced, and mossy fibers will be weak. They'll be more frequent, but they'll be weaker, and climbing fibers will be the opposite. So that's it.